I want to conclude this basic introduction to TypeScript with a slightly more advanced yet very important TypeScript feature, and that would be generics. Now, this can be tricky to wrap your head around, but I'll try my best to explain it such that it makes sense. Let's say we have a function here, which I'll name insert at beginning, and this function takes an array and a value as parameters, and the array should be an array full of any kinds of values, and the value should be any kind of value, because I don't care in this function if it's an array full of numbers or strings or of person objects. Whatever it is, what I want to do in this function is I want to create a new array, for example, by using the spread operator and copying the existing array. That's a standard modern JavaScript feature, also supported by TypeScript. And then in front of that old array, I want to insert the value. And then I want to return this new array here. That could be a utility helper function which we create to have a function which we can easily call to add a value in an array without changing the existing array. So the advantage of this function could be that the original array never changes, but instead we're getting a brand new array. Now for this, I could of course have a demo array with, let's say, 3 values. And then I get my updated array, where I call insert at beginning, and I pass in the demo array, and then a value of -1, let's say. With that, I know that the updated array will be this array with -1 inserted at the beginning. So this will give me -1, 1, 2, 3. And hence, thereafter, I might want to do things with that array, which I can do with an array full of numbers. But the problem is that updated array, if I hover over it, is inferred to be of type any array. So an array full of any kind of values. TypeScript here doesn't pick up that it's an array full of numbers. Why? Because here I have any as a type. And I can't say that I only want to allow numbers here, because what if I want to use this utility function with an array full of strings? So we need any, but at the same time, that kind of removes all kind of TypeScript support we might be getting after calling this function. We're not getting any good TypeScript support for updated array thereafter, because that is inferred to be an array full of any kind of objects or any kind of values. And that's not useful. If I then, for example, try to access the first element and call split here, which I could call on a string, I don't get an error here. I would get a runtime error instead, because I can't call split on a number. But again, TypeScript doesn't know that the first value in updated array is a number. We know it as a developer, but because of our type definitions here, which we need, TypeScript doesn't know it. And to work around such problems, we have this feature of generics. And that's why I had this lengthy introduction here, because it is important to understand why this feature exists. With this generics feature, we can convert this function to a generic function. For this, we use a special syntax here. After the function name, in front of the parameter list, we add angle brackets. And that's now not a standard JavaScript feature, but really only a feature we can use here since we're using TypeScript. And in here, we can define a generic type, which will only be available inside of this function. Typically, that's called T for type, but any identifier of your choice is okay. Now you can use this type in your function, including the parameter list. And here I'm saying, I want to use this for my array. So my array will be full of t's and my value. This should also be of type t. But how does this help us? Well, like this, it of course is just very cryptic. But now when we call this function, now TypeScript actually is able to understand that it should look at the concrete values of the arguments here, And it understands that this is an array of numbers and this is just a number, and therefore it understands that updated array will be an array of numbers. Because of this generic type feature, because we're telling TypeScript that the type here is actually not any type. It's not any kind of value. Instead, we tell it that the type of this array and of this value should be the same. Just that this is an array, but it's an array full of the same types of values as this single value has it. And that's an important piece of information. Therefore, TypeScript is able to look at the type of demo array, which it knows. It knows that this is an array of numbers. It's able to infer this. And it looks at this type. And then it knows that logically, the array which gets constructed here has to be of the same type as the input array. It's able to infer this here. And hence, it's able to infer that what we get back here has to be an array of numbers. And if I would call insert at the beginning here with an array of strings like this, and I then pass in a string here, and I have my string array here, TypeScript is also able to infer this correctly. Because again, it looks at this type, and it knows that the return type is of the same value as this type, as the input array, and hence it again infers this correctly. And therefore, for the updated array here, where it knows that it has to be an array full of numbers, it's now able to warn me when I try to call split. It tells me that this does not exist on type number. So that's this important feature of generics. It simply helps you write functions, in this case, which are type safe yet flexible. They are flexible, they work with any type, but then once a certain type is used, for that function execution, that type is locked in and known. And that allows you to get the best of both worlds, flexibility and type safety.